This is a video of our 4th lesson in the unit on rational functions and equations. A lot of you are watching this video because of the early release due to weather, so go ahead and turn to page 23 and complete the warm-up. The first thing I notice is that, you should have paused the video already and done this. The first thing I notice is that the denominator is x plus 1, so my vertical asymptote is going to be at x equals negative 1. I've got a plus 3 on the outside, so my horizontal asymptote is going to be y equals 3. I know immediately that my domain will be all real numbers, but x cannot equal negative 1. I'm going to wait on the range. So I'm going to fill my table in. Negative 1 is going to be undefined, and I will go ahead and do negative 2 and 0. Now when I put 0 in, that's the easiest. I immediately find out that it's 5. If I put negative 2 in, I also get 5. So let's graph. Here's my vertical asymptote. Here's my horizontal asymptote. And I have 2 points that are symmetrical. I have one here and I have one here, and that doesn't surprise me based on the parent function. And there we go. So here's our graph, and now that I've made the graph, I know the range is y is greater than 3. On the left, as x goes to negative infinity, y goes to 3, and on the right, as x goes to infinity, y also goes to 3. I have 3 transformations. I have a vertical dilation of 2. The graph is going left 1 and up 3. And if I rewrite it, I get g of x equals 2, and then f of x plus 1 plus 3. Okay, today we're going to look at some situations with different discontinuities. So go ahead and turn to page 24. The top of page 24 says, Augustina says, to determine the location of a vertical asymptote of a rational function, all you need to do is find the values of x that make the denominator equal to 0. Do you agree with Augustina? Well, I have to tell you, at first, based on our knowledge so far, yes, I do agree. And the reason I agree is, like, if I have something like y equals 1 over x, I have a vertical asymptote when the denominator is equal to 0. If I have y equals 1 over x plus 4, I have a vertical asymptote when x equals negative 4. I mean, like, this is basically what you did in last night's homework. You took the denominator, you thought to yourself, what makes the denominator equal 0, and that was your vertical asymptote. So let's take a look at number 2. Number 2 says, use technology to examine the graphs of the 2 equations below. How are they similar and how are they different? Before I even go to technology, I'm going to look at the structure of these functions. And I notice the way they are written, they have the same denominator. However, they don't have the same numerator. So this has a 1 and this has an x minus 3. When I look at the first function, I notice that 3 will make this denominator equal to 0, but 7 will also make this denominator equal to 0. When I look at the second one, 3 will make the denominator equal to 0, 7 will make the denominator equal to 0. But I notice there's this x minus 3 in the numerator, and I'm wondering how that will affect the graph. So what I'm going to do is I'm going to graph both functions. I have 2 calculators with me. I'm just going to put some other parentheses in that if you are graphing along with me, you will need to add them in. Otherwise, your typing will have problems. So I'm going to go to y equals, and I've got 1 over x minus 3, oops, and then x minus 7, close, close, and there's that graph. Ooh, funky. Now I'm going to do the other one on the second calculator. I'm going to go parentheses x minus 3, close it, divided by parentheses, parentheses, x minus 3, x minus 7. So if we were doing this in class, I would have half the group do one and the other half do the other and have you compare. So if you want to do one and look at the other one for mine, that is up to you, or you can just look at both of mine. So here's the second graph. Oh, that is a messed up window. Okay. Now I notice my first graph indeed does have 2 vertical asymptotes at 3 and at 7, but my second graph only has a vertical asymptote at 7. So I'm going to put my calculators off to the side for a second, and I'm going to just make some notes. Here I have a vertical asymptote at x equals 3 and x equals 7. I also have a horizontal asymptote at y equals 0. For this function, we're going to wait on this guy for a second. So I'm going to go 1, 2, 3. And then I'm going to go 4, 5, 6, 7. And I'm going to look at my calculator, and I see I had like something come up in the middle. And then I went like this. And I'm going to make a note that I have a domain of all real numbers, but x cannot equal 3 or 7. And I have a range of all real numbers, but y cannot equal 0. Okay, so when I look at that second function, and I look at its graph, it only has an asymptote here at 7. And here is why. I can cancel out x minus 3. But when I do that, I want to make a note that even though I've canceled out, I still have discontinuities at x equals 3 and x equals 7. I have discontinuous points there, but because x minus 3 cancels, it is not a vertical asymptote. It is a hole. All right, so that's new. X minus 7 doesn't cancel, so it's going to be a vertical asymptote. So let's start to list our discontinuities here. We have a vertical asymptote at x equals 7. Nothing new there. So I'm going to go over to 7. 1, 2, 3, 4, 5, 6, 7, and dot it in. Now I'm going to have a hole, and I'm going to explain what that looks like in a minute, at 3 comma something. Now I need to figure out what the other coordinate of my hole is. So what I'm going to do is I'm going to take what I call the compressed function. Now this is not like an official title. I just call it the compressed function. I think that vocabulary makes sense because when I cancel it, I've kind of compressed it down to 1 over x minus 7. And I'm going to put 3 is going to go in for x here. So I've got 1 over 3 minus 7, which is negative 1/4. So at 3, negative 1/4, I have a hole. So I'm going to just take another look at this graph. Here's 3, and I don't see anything, like I don't see anything fancy there. But if I go look at my table, and I look, oh, there's like a, there we go, that's better. And I look, oh, there it is, 3 says error. Just like 7 says error, because I have discontinuities at both 3 and 7. So I'm going to graph 3, and then I'm just going to go down a smidgen, and I'm going to put an open circle there like a hole, and then I'm going to make my graph around it. That's how you graph a hole discontinuity or a point discontinuity. Now, honestly, we really should like get nicer points there, but for now, I want to get this video done before the bell rings and someone walks in on me. It makes a lot of noise, so it'll be good for now. So I've got a vertical asymptote and I've got a hole. I also still happen to have that horizontal asymptote at y equals 0. I want to look at the range. The domain and the range is still the same. Okay. So let's revisit Augustine's claim. Has our view changed at all? Yes, it has. I'm going to write up here because I don't really have, I don't know, maybe I'll have enough room. Let's see. No, definitely not. I'm going to write my answer up here. Okay, so the values of x that make the denominator equal to 0 will be discontinuities. Not necessarily vertical asymptotes, but they will be discontinuities. Okay, so if the factor doesn't cancel, like for example the x minus 7, it didn't cancel. If the factor does not cancel we have a vertical asymptote. But if the factor, forgot the the there, oh well, if it does cancel, we have a hole. I don't know why I wrote that in all caps. All right, so let's take a look at page 25. Page 25 is asking us to explain the similarities and the differences between these two functions. So the first thing I notice is that f of x has this funky denominator. So I want everyone to pause the video and factor this denominator. Okay, at this point you should have factored the denominator. If you need a little help, let's remember AC is -6. And I need two things that add and multiply, and that would be negative, so I'm going to go 2x squared minus 3x plus, so those are my numbers, and then I'm going to take out an x, and I've got 2x minus 3, I'm going to take out a 1, 2x minus 3, and so now I've got x plus 1, 2x minus 3, and I'm going to rewrite f of x now, keep my numerator. Okay, so when I look at f of x and I look at g of x, they share this factor. But f of x has this x plus 1, and the x plus 1 happens to cancel. So I made a Venn diagram earlier in the day. Thank you to the person who suggested that. I can't remember who it was, but it was a good idea. So we did f of x. Ooh, those are uglier circles. It came out better on the Promethean board. So we have f of x, and we have g of x. I didn't really need such a big circle for g of x. That's okay. What do they have that is the same? They both have a vertical asymptote at x equals 3/2. And just as an FYI, I got that. I just did 2x minus 3 equals 0, and then, like, you know. Okay, so there we go. They both have that vertical asymptote. But f of x has a hole at -1. Ooh, I don't know what the hole is. So what I'm going to have to do is I'm going to have to take this compressed function, 1/2x minus 3, and I'm going to have to put -1 in. 2 times -1 minus 3 would be -5. So -1, -1/5 is my hole. Okay, so that's the hole. Do they have anything else in common? Yes, they both have a horizontal asymptote at y equals 0. They both have the same domain of all real numbers, but x cannot equal 3/2, or, no, they actually don't have the same domain. That's a lie. It's a lie! Show some whiteout tape. The domain here is just all real numbers. Now, if you're in my first class, I just realized the notes are wrong, so whoopsies. Here we have a domain of all real numbers. X cannot equal 3/2 or -1. They have the same range though. The range is going to be all real numbers. Y is not equal to 0. So that's pretty much it. Like g of x doesn't have a hole. If I wanted to write like there's no hole here, that I could do that. But that's the similarities and the differences. So your homework tonight is a separate worksheet. Hopefully everyone picked one up. If you didn't, I'm going to put it up here. It's really just 2 problems. You can write them down and do them on your own and have them on a separate sheet of paper. Be ready to hand them in when you walk in on Monday. Have a great weekend. Thanks for watching.